Okay, so we're going to look at solving right angle triangles, and we're going to look at SOHCAHTOA. So last class we talked about tan, so today we're going to focus on sine and cosine. So what do these things even mean? I mean, they're just these random weird words, right? So in a right angle triangle, has to be a right angle triangle, right? That's important, okay? We're going to call this my angle of interest. So this is the angle I care about. Because I care about that angle, the side that touches it is my adjacent, okay? And the angle that's all the way over here is my opposite, okay? And the long side here is my hypotenuse, right? Really long word for a really long side. And the whole point of these labels is because they've come up with these really great ratios for these angles, okay? So sine of an angle is my relationship between the opposite side and my hypotenuse side. So from here, well, that means that sine is my opposite over hypotenuse. That's where it comes from. Okay, so that means that anytime I have an angle with one specific angle, I will have the same relationship between my opposite and my hypotenuse. So let's look at that. Okay, before I go any further, let's look at that one. So let's say I have a triangle. So there's my lovely triangle. And I don't know, let's say this side has a length of 10. This side length has a length of 20. What's my angle in here? Okay, so we can solve for that. Sure. There's all the way over here, so this is my opposite. This is my longest side, so this is my hypotenuse. Okay. So that means I want to use sine, which is my opposite over my hypotenuse. So sine of that angle is equal to 10 over 20. And to get the angle all by itself, this is where I have to use my second function on my calculator, right? So I need to use my second function because I'm going to have to get this sine minus 1 business. Because I need the sine inverse. That's my sine inverse. Sine inverse of this 10 divided by 20. And calculators nowadays are pretty good, right? I don't need to look up a crazy table like I did last class. So I would do second function sine. I want that sine minus 1 showing up on my screen. Type in your 10 divided by 20 and close your bracket so your calculator knows what you're doing. And when you hit enter, you should get an answer. Oh, look, I have a 30-degree triangle. Oh, cool. So the cool thing about this ratio is that if I wanted another 30-degree triangle that's maybe a little bit bigger or a little bit smaller, I can figure out how long my other side is going to be, right? Especially if you're in art or architecture or something, like you might want to scale something. So let's look at what that means. So if I have another identical triangle that I just want to have a little bit bigger, let's call it bigger. So there's 30 degrees. And let's say instead of a 10 centimeter piece on this side, maybe I want to have a 40 centimeter piece on this side. So how long would my hypotenuse end up being? So it's still a right angle triangle. And I want to have the same angle, I just want to make it bigger. Well, we can figure this out. Again, this is still my opposite side. This is still my hypotenuse side. So that means I can use my ratio of sine angle is opposite over hypotenuse. So I've got sine of 30 degrees is 40 over x. Now here's where I often see a lot of creative solving by students. So probably the easiest way to look at this and rearrange it properly is if I make this an over 1 fraction. I can cross multiply. And then I don't mix up my my order here. So that means x is equal to 1 times 40 divided by sine 30. Okay? Because you got to make sure you get it in the right order or it doesn't work. So I can calculate that. So I'm going to do, well, 1 times 40 is just 40, divided by sine 30, because sine 30 is a number. So we got to type it in, 40 divided by sine 30. Hit your equals. And my hypotenuse is now 80, what am I, centimeters? 80 centimeters long. So does that make sense? This was a 1 times a 2. And here's going to be a 40 times a 2. So my sine gave me the right relationship in here. Yay, sine. Okay, so that was sine. Let's look at cosine. So cosine, well, which pairing haven't we looked at yet? So let's remember, here's my right angle triangle. And if this is the angle I'm interested in, then the one right beside it is adjacent. Over here is my opposite. And my longest side is hypotenuse. Okay? So we figured out that cosine is opposite over hypotenuse. We figured, sorry, sine is opposite over hypotenuse. Tan, we did last class, is opposite over adjacent. So what's left? Adjacent over hypotenuse. Adjacent over hypotenuse. So let's do some stuff with cos and see what we see. Okay? So, I don't know. Let's pick a random triangle to look like this. And let's maybe give you an angle. And this time, let's give you an angle. Let's say this is 55 degrees. And I'll give you an hypotenuse, I don't know, what's a good number? 80? Sure. And let's call it inches this time, because why not? And let's figure out what this side is. And I'm picking this side because I want to use my cosine. Okay, so here's my angle of interest, which means this is my adjacent side. This is my longest side, which means it's my hypotenuse. So let's use cos of the angle is adjacent over hypotenuse. And what's my information? Pop it in. So I've got a 55-degree angle. My adjacent is what I'm looking for, and my hypotenuse is 80. So this one's a nice straightforward rearranging. So instead of dividing, I'm going to multiply both sides by 80. So when I go to type things in my calculator, I'm going to type in 80 times cosine 55. And I'm going to type it all in exactly like that. You don't have to do anything crazier than that. So let's see, 80 times cos 55. So I'm going to type it in just like that. Okay, hit your equals. And I have a adjacent side of 45, round that to 0.9, what did I say? Inches. Self-check. Is it smaller? Yes, it is. We did it right. Good. Okay. Sure. Should we do another one? Let's do another one. Let's do one where we have to find the angle. Do we want to find the angle? Ooh, let's do one where we have to find the hypotenuse and practice that whole rearranging business again. So here, and let's change it. I'm going to put a 60-degree angle up top here. I'm going to look for my hypotenuse, and I'm going to tell you that this side is, I don't know, 4.5 feet. Why not? Okay, so because this is now my interesting angle, this becomes my adjacent because it's right beside my interesting angle. Longest side is always the hypotenuse, okay? And because I'm dealing with adjacent and hypotenuse, adjacent and hypotenuse, I have to deal with cosine. So cosine angle is adjacent over hypotenuse. Cosine 60, put in what we know. Adjacent is 4.5. Hypotenuse is what I'm looking for. So simple rearranging doesn't happen right now because my unknown is in the bottom. So I'm going to say divide by 1 because everything's divided by 1. cross multiply. So you end up with x equals 1 times 4.5. So you multiply the diagonals, divide by the other guy, divide by cosine 60. Type it just like that in your calculator. You can even type in the 1 times if you want. Divided by cosine 60. Okay. Oops. I don't know if you can see it all. So there's my 45 times cosine 60. Enter 9. Oh, I like that one. 60-degree angles are really cool, actually. It's a 1, 2, root 3 relationship. So this side is always going to be half the long side. So long side is always twice the side beside the 60. It's really cool. Always. Always. This is a special triangle. So any triangle with a 60 degrees here, if this is x, this is 2x. Always. It's really cool. Okay, so let's do another question. And this time, I'm not going to tell you which one we're going to use. We're going to figure that one out. And I'm going to throw a little bit of other stuff in there for us. So, let's say I have a person standing here. Okay? And they see, I don't know, let's say a bird. That's my bird. And let's say we want to figure out some of the values that we have in here. So there's my bird. I don't know. I'm not an artist. I don't even know what that looks like now. Okay. So there's my bird. There's my person. Yay, happy math person. Okay. And let's see, what are some of the things I could figure out? We can talk about what's called our angle of elevation. Which means if I look out straight and as I look up, what angle did I look up at? That is my angle of elevation. Okay. And let's say I had to look up at an angle of, I don't know, it's a bird, say it's way up high, say 75 degrees. Okay. I don't know, let's say it's 75 degrees. And let's say it's on top of a tree that is 10 feet away. Well, how high is it in the sky? And how far away is it from me in person if I were to reach out and touch it? So I want to figure out both pieces. Well, we got a couple of different ways. We now have 3 different ways to put together these different triangles. So let's think about this. I have a triangle I made really messy, so let's clean it up. I said this side is 10. I said this angle is 75 degrees. And if I think about it, I know cosine is adjacent over hypotenuse. So why don't I figure out for my hypotenuse? Let's figure this guy out. So there's my angle of interest. So this is my adjacent. This is my hypotenuse. And one of the ways, like if you don't have confidence in yourself, we'll just write down the SOHCAHTOA and check off what you've got. So I have an adjacent. I'm looking for a hypotenuse. So the equation that gets the 2 checks is the equation I'm going to choose. So that means this is going to be a cos angle is adjacent over hypotenuse. So let's sub in and solve. So cos 75 degrees is 10 over x. Oh, there's that crazy rearranging again. All right, let's do it. X is 1 times 10 over cosine 75. Toss it in your calculator, and what do you get? Clear. 10 divided by cosine 75 equals 2.6. What are we in? Feet? Oh, something didn't go right. Oh, I times it. You gotta divide it. 10 divided by cosine 75. Well, that makes more sense. 38.6 feet. I couldn't have a hypotenuse that little. I need a big number. Big number. Big number. Okay. Let's see. If I want to figure out this side length now, let's go back. I'm going to clean it up. I made a big mess again, so let's clean it up. So I'm looking for this side. I know this is 75 degrees and this is 10. And I now know that my hypotenuse is 38.6. So I can now use any of my triangles, really, that involves this side. So if that's my special angle, this one is my opposite. This is my adjacent, so opposite and adjacent, I could use tan. This is my hypotenuse. So which equation uses opposite and hypotenuse? Well, today's all about sine and cos, so let's use sine. It over hypotenuse. I know I have a 75-degree angle. I'm looking for my opposite, and my hypotenuse is 38.6. So since I have a number underneath, I can times both sides by that, right? Opposite of division is multiplying. Put that in your calculator, 38.6 times sine of 75. Calculator. So what do we get? Well, type it in. 38.6 times sine of 75. And I get 37 point, let's round that to 3. And what am I talking about here? Feet. Therefore, the bird is 37.3 feet high. And what's this? 38.6 feet away from me. Okay. Okay, so let's just do one more example where we're solving for the angle, because we've done a lot of side solving, we haven't done a lot of angle solving. So there's another special triangle, and it's the 3, 4, 5 triangle. So that's one, I know I'm doing them all in the same shape today, where one of the sides is 3, one of the sides is 4, and my hypotenuse ends up 5. Okay? And I want to know, what are my angles? So, let's solve for the angles, and let's do both, and let's see if we even get it right. I don't know, maybe I did it wrong. So, there's my angle. That means this is adjacent, and this is hypotenuse. So, let's use cos first. Adjacent over hypotenuse. And I want to solve for my angle. So, adjacent is 3, hypotenuse is 5. Remember to bring the cos to the other side to get the angle by himself. I need to do the cos inverse. And when you type it into your calculator, right, make sure you divide. So what does that angle equal? Let's see. Second function cos, right? Second function cos, you need that cos minus 1. 3 divided by 5. Close your bracket. Close your bracket, people. Close your bracket. Equals... well, that's 53 degrees. Let's check and make sure we did things right. Sometimes I don't write things properly. I don't know. And let's see if I get that same answer if I use sine. So remember, the sine ratio is dealing with opposite over hypotenuse, right? So is opposite over hypotenuse. So sine of the angle is opposite is 4, hypotenuse is 5. Bring your sine to the other side. So this time you're going to do second function sine 4 divided by 5. So if we did it right, we should get the same answer. So second function sine 4 divided by 5, close bracket, right? Right? Enter. Hey, look, we got it right. 53 degrees. Don't you just love when things work out properly? I do.